This conference
for
will
our.
now be recorded.
Thank you so much, ma'am G. All right, guys. So the topic of the day is VXLAN. Guys, this is a very important topic, not from his own point of view, but also to understand the next topic called application-centric infrastructure. In the next topic called application-centric infrastructure, we will be using the same topology over here as we are going to discuss here, plus the VXLAN, what we are going to configure, learn over here, that VXLAN will be implemented over there in ACI Fabric as well. But ACI Fabric is not going to ask us to configure the VXLAN. ACI Fabric, he himself will configure the VXLAN automatically. That is the beauty of ACI. But we should not try to skip because VXLAN will be configured over there. So VXLAN starts over here. Anand has arrived. Anand, thank you so much for joining. I appreciate all you guys who are joining so early morning. This shows your curiosity to learn. So VXLAN. In this particular topic called VXLAN, we are going to study about the VXLAN topology, the difference between underlay and overlay, understanding overlay based data centers, then evolution of VXLAN, various terminologies as used in VXLAN, because there are going to be so many new terminologies, right? When it comes to new terminologies, we will try to see the analogy, we'll try to establish analogy of those terminologies so that we could be comfortable, right? All new things are nothing but advancement of the old ones. VXLAN deployment modes, and then finally a deep dive understanding of MPBGP EVPN control plane and distribution of host reachability. Why is it so important? It is so important because when we have understanding of the MPBGP EVPN control plane, then our lab understanding with regards to each and every task wherein we are going to have 6 tasks will be more clearer, because in the lab with regards to each and every task we need to do the verification. Guys, during this particular journey of VXLAN, on day 2, that is tomorrow, I'm going to take a pause. I'm going to give a pause to VXLAN because something called multicast, right, which is really very important and is used holistically in VXLAN, needs a revision. I know that all of us know about multicast, but very few of us would be knowing about the configuration of multicast, what multicast does, and then the role of multicast in VXLAN. So only one day on multicast, by giving a pause to VXLAN, we are going to learn. So these are the topics in VXLAN. And once the topic is over, then we will be spending significant amount of time in order to understand our lab with each and every individual task. There are 6 tasks. So you can say more than 6 days we will be spending, because certain tasks we will not be directly configuring unless and until we understand. Though the theory component will be over, but I do understand with the theory component over, you would have tons of questions, and those tons of questions would be answered in the VXLAN lab. All right, so let us start our journey over here. First of all, the VXLAN topology. Guys, probably you have gone through. Sandeep Nair has arrived, Vipin Gautam has arrived. Thank you so very much, guys. Thank you so much, Sandeep, for joining. Yeah, I dropped you a message early morning. Another friend of mine, Jai Ganesh, he requested to join this batch. He is there in evening, but no, he is not here. All right, no problem. So the topology where we do implement VXLAN. Guys, we all know about spanning tree protocol. Rasul, thank you so much for joining. Spanning tree protocol. We all know about spanning tree protocol. Spanning tree protocol, who developed it? Okay. A lady by the name of Radia Perlman. Thank you so much to this particular lady who developed spanning tree protocol. Spanning tree protocol, we know, is a loop avoidance mechanism, right? Now, why the loop occurs? Loop occurs because not of the north and south connectivity, but at the same time, east to west connectivity, wherein a complete loop gets formed among the switches. And to mitigate, spanning tree protocol, what spanning tree protocol does? Blocks one of the interface. Guys, much before this particular topology was designed, well, it was in the year 1938 that Mr. Edson Erwin, he proposed one particular topology, which was later on formalized in year 1953 by a gentleman called Charles Claus and adopted by a company called Bell Telephone. That was nothing but a topology to connect the circuit, to connect the telephone network, better, simple, which was providing circuit switching. All right. Now, then Radia Perlman realized it, and she introduced a concept called trill, transparent interconnection of lots of links. This trill became an industry standard protocol. Later on, Cisco introduced a concept, called fabric path. Well, was based on the same. Guys, fabric path was there in our CCIE data center version 1.0. Starting from 2.0, Cisco decided to replace fabric path in the lab with VXLAN. Continued in 2.1 with a new flavor of deployment flavor of VXLAN, and definitely is playing a very significant role in the data center release 3.0 as well. Okay, well, so what was this transparent interconnection of lots of link? Guys, this was based on a topology which simply and commonly known as spine and leaf topology. Well, this topology is also known with the name of that guy who formalized it, called clause. So we can call it to be as a clause network or clause architecture. What is the beauty of this topology? The beauty of this topology is that it gives us two layers. One is spine and other is leaf layer, wherein this topology holistically says, sorry, spine to spine connectivity will not be there. Leaf to leaf connectivity will also not be there. The connectivity will only be the north to south connectivity, no east to west or any lateral connectivity will be there in this particular topology. Why? Because it was seen very well that providing a lateral connectivity or east to west connectivity, what happens is the layer 2 loop occurs. When layer 2 loop occurs, we need to recall Lady Radia Perlman and block one of the interface. Guys, today, each and every company needs redundancy. Today, each and every company organization needs what? The optimization of the cost. That is, each penny spent should be each penny earned. In fact, more than a penny earned. So we have spent the penny on this particular port. Why should we block it? Why not to use it for a more productive purpose? That's what we don't want to block. So having this holistic approach, this particular topology was formalized first in Trill, then in Fabric Path, then in VXLAN, and then in our application centric infrastructure as well. All right. The beauty is this particular topology provides us equal cost multipathing, uniform reachability, deterministic latency, high redundancy. These are all 4 marketing bullet points. We are not, and I am not selling any product to you. So no marketing. We will be diagnosing them whether they are really true or not. The connectivity, how the connectivity gets established. All right. Now, before understanding our VXLAN, VXLAN in simple we can say it is an overlay. Overlay means it is a tunneling mechanism. Objective, the layer 2 to layer 2 as well as layer 2 to as well as layer 3 to layer 3 communication. We'll take a deeper look into it. But important point is before setting up VXLAN, right? As we all know that BGP is a connection oriented protocol. To even have a BGP neighbor relationship, we want a reachability. It's a connection oriented, we want a reachability. Same, the VXLAN believes that in order to set up a VXLAN overlay or tunnels, you need to provide me layer 3 connectivity or reachability between the endpoints, between the tunnel endpoints. So we all know what is underlay. Underlay is nothing but it is something which is called as layer 3 reachability, right? And this layer 3 reachability is achieved with the help of either which routing, with the help of routing, which routing, either static or dynamic, right? Static or dynamic. So first and foremost prerequisite to get our VXLAN configured and to understand it, we need to establish an underlay. Okay, we are working predominantly on the underlay configurations only when it comes to our daily day-to-day life. VXLAN is on top of it. So what underlay provides? We are well versed with the terminologies like layer 3 interface pairing. We know what is an IP address. The edge devices in this, they are the endpoint devices where AND hosts are connected, like AND hosts can be virtual servers, physical servers, and all. The devices where these edge these virtual servers or physical servers, the switch where they are connected to that particular device in underlay is known as edge device. Then we talk about the LAN segment, the segment where endpoints are connected to the edge devices. But in case of VXLAN, the terminologies, in case of overlay, let's talk about the terminologies are different. In case of overlay, first and foremost important, before even going to the terminologies, we need to understand what are the different flavors of overlay. And in order to tell you this, I really need to zoom specifically these endpoints over here, right? The endpoints, because they are so small, you will not be able to see and understand. But network overlay, something I can start without zooming it. What is network overlay? Over here, it is, of course, overlay is nothing but it is synonymous of creating tunnel. All right. We have a VPN tunnel, GRE tunnel, right? So many tunneling mechanisms are there. L2 VPN tunnel and all. In fact, overlay is also a tunneling mechanism wherein we require two endpoints, minimum two endpoints, right, to establish a tunnel. And those endpoints are known as VTAPs. We will be coming over to these terminologies in detail. VTAP stands for VXLAN tunnel endpoints, where we establish our tunnel on the physical, right, leaf switches. Then that particular overlay is known as network overlay. Yes, we will be labbing using network overlay, right? Okay, so over here, these devices are what they are, our physical switches, definitely with the capability to allow tunnel creation for, say, VXLAN. Now, let me move it out from this mode, and I need to zoom specifically to explain you what is host overlay. So here we go. I need to bring it more closer. As much as 400% is the maximum zoom which is possible. So we are looking at into what is, all right, here, what is host overlay. In case of host overlay, kindly take a look. Kindly take a look on the tunnel endpoints now. The tunnel endpoints are no more. Jai Ganesh, welcome. Thank you so much for joining. I was just remembering you. In case of our host overlay, our leaf switches, they are no more the tunnel end points. In fact, the tunnel endpoint is moved over to a virtual, switch. Now the question comes is, what the heck it is with regards to this virtual switch? What do we see? What is written over here? This is something written as hypervisor. We tap on where? On hypervisor. Guys, this also we are going to learn in our topic called ACI with regards to a lab called VMM integration. And yes, you will be creating this particular switch, right? Not from the point of view of creating a VTAP on the switch. That is also possible, and that we definitely do, right? But in where? In NSX, which is VMware's network virtualization solution. All right. In case if you happen to join, or I happen to start teaching NSX also, there, this will be an important agenda. All right. So in case your tunnel endpoints are not the physical switches, but the virtual switches, we call them as, VDCs, virtual distributed switches, on both the sides. normal on both the sides. All right, that particular overlay which we establish is known as host overlay. In case of, let's go on the right. In case of network overlay, our tunnel endpoints are physical. However, in case of host overlay, right, our tunnel endpoints are virtual switches. All right. Then comes a mixture of both of them, which is known as hybrid overlay. In case of hybrid overlay setup, one side you will have, okay, pen again. One side you will have your virtual switch here, right, which is going to give you a tunnel endpoint. Other side, you are going to have physical switch. So wherein you have virtual switch on the one side called VDS, virtual distributed switch, a beautiful name, and a physical switch on the other hand. We call this tunneling overlay as hybrid overlay. I'm sure this is clear to you, right? Why I told you this is simply to make sure tomorrow, in case if you happen to configure hybrid or host overlay, you should be comfortable with the topology, the devices. So in our labs, indeed, as I said, we will be configuring network overlay, right? Well, in case, as I said, you get a chance to work on and learn VMware's network virtualization solution called NSX-V or NSX-T. NSX-T is the latest. You will definitely get a chance to create hybrid, in fact, host overlays. Hybrid in case other end you have switches, physical switches. So that is possible in the data centers as well. And yes, engineers are doing it. All right. Now the terminologies, as we have seen terminologies in underlay, now there is a refinement in the names to the same devices once they are configured in our overlay. The edge device in underlay now is known as VXLAN tunnel endpoint. Why? Because from this device we are going to create tunnel to a remote VTAP device. From here and here and so on. So such devices are known as VXLAN tunnel endpoints. The servers are definitely called virtual and physical. And this particular segment, this is a LAN segment, but at the same time, this LAN segment is associated to another terminology called VXLAN segment as well. As LAN segment is identified with the help of VLAN ID, this VXLAN segment is identified with the help of VXLAN network identifier. For the purpose of sending the traffic onto the VTAP device, the VLAN, say it is 100, this VLAN goes inside the VTAP device and VTAP device provides a VNID, which is, say, for example, 50100. That is, in order to send the traffic inside the tunnel, we need to encapsulate, and that is nothing but, in a simple words, that is the job of our VXLAN tunnel endpoint. This happens in the course of our configuration. Well, VXLAN configurations are humongous. Yes. In case if you have any doubt, yes, please. I
Sir,
love
so
to.
eh, yes, so you're saying this VTAP virtual tunnel endpoint can be on the last switch, or we can say the access switch, or it can be on the direct on the hypervisor or bare metal. So that is also possible.
That's what in overlay types I told you. It is possible on the access switch is not a right terminology. Why? Because switch needs to have a capability. All the switches, they don't have capability to configure the VTAPs and all the VXLAN related configuration. Only a capable access switch, right? Only a capable access physical switch VTAP device is configured, VTAP is configured, or in case of virtualized network world, it can be configured on a distributed switch, right? Vipin?
Right. I got you. So, uh, are we going to discuss this you said one term VNI in detail?
Absolutely. In
Okay.
detail, in depth, without which no point of starting the configuration. VNI, VXLAN, right? VNI, VNI stand for VXLAN network identifier. Very important term it is, and it has got two variants, L2 as well as L3. We are going to discuss both of them, and then we will configure them as well in our lab. It is going to be a beautiful journey, guys, and if you stay in this particular journey, be regular in this journey, and try to do little hands on this journey, you will come out to be very strong in VXLAN. There are a lot of tons of commands. Systematically, we are going to understand them. Okay. So with this introduction of VXLAN, let us come to some theory of it. What is VXLAN? Full form. Let's begin with full form. It stands for the very first word, virtual, extensible LAN or local area network. Here, the industry standard says we are having a VXLAN. Where is why I'm losing my pen? Why we are calling it as VX? Because just a matter of style. We don't want to call it as VELAN, right? It was decided by the industry that we will call it as VXLAN. We will just put X in an uppercase. X also known as extra extended, right? So fine. What is this VXLAN? Theoretically, it is a layer 2 in layer 3 overlay tunnel. Layer 2 means what? Layer 2 means a frame. Frame where it is originated from a switch. Now needs to be sent remotely. So what we do is we will encapsulate it with layer 3 header. But not only layer 3 header, the frame. Before adding layer 3 header, we will add transport protocol called UDP in front of it, and then we will add layer 3 header. Layer 3 header means what? IP addresses, IP header. So the original frame, right, gets encapsulated first by UDP header and then by our detailed IP header, which is nothing but which provides us source IP and destination IP to the frame so that the frame can fly and reach to the remote end. All right, because we don't have the Cisco's proprietary overlay technology, OTV in our data center version 3.0, we have skipped it. Officially, it is being removed from our data center version 3.0 curriculum. It was there till 2.1. All right. It is to have more numbers of layer 2 segments via multi-tenant environment. Guys, today, a buzzword, very important buzzword which is going on is everywhere is known as multi-tenancy. Here in our VXLAN understanding, we will get the first glimpse of multi-tenancy. Multi-tenancy in case of routing world is achieved through a beautiful concept called VRF, virtual routing and forwarding. Well, this concept is not the new concept when it comes to VXLAN in our service providers network, where our service provider IOS XR router is connected to multiple customers. What do they provide? They provide individual VRF, individual logical router to each and every individual customer. So that is nothing but, that is, you can say, a predecessor to the terminology called multi-tenancy. Multi-tenancy is the latest technology. Better to call it not a technology, a terminology, because this is what we are implementing in our public cloud. All right. So VXLAN supports it. VXLAN provides a multi-tenant network. Requires more detailed understanding of it, then you will understand. And when you will come to ACI, where you will be asked to create different tenant structures, then you will understand the logic of it, the practical logic of it. Okay, we have this in our pipeline. Open standard, RFC, request for comment 7348, first time talked about virtual extensible local area network. So this means wherever something is published in RFC, this means what? This is an industry standard protocol. Then some enhancements was done in VXLAN, where we thought of scaling VXLAN, right? And thus the enhancements was published in RFC request for comment ID 7432, and that was the enhancements with regards to MPBGP, MPLS based L2 VPN, and this we call as introduction to EVPN. Today, with regards to each and every deployment, this is the deployment of VXLAN out of 3 deployments we are using. Well, coming over to our CCI data center, version 2.0 was not having MPBGP EVPN based deployment. Version 2.1, it started having MPBGP EVPN based deployment of VXLAN, and this is what we are going to learn in this particular course. Guys, if you want to interrupt me in between, feel absolutely free. I love to get interrupted because it gives me a chance to sip some water.
Ashish, what about the UDP? Which port they use?
Very good question. Since the question is being asked, in the frame, when we add the UDP on top of it, there is a source and there is a destination UDP port. Source UDP port is dynamic and destination UDP port is 4789. That is, the quick answer is 4789. I will show you this in another few minutes while deciphering, while dissecting a VXLAN header. Now, though VXLAN, hope this is clear, right? Simple. Come on. Please never forget,
Yeah,
this is very important question, guys. Very important question. What is UDP port number for VXLAN. You open your VMware network virtualization platform called NSX. VXLAN is configured over there. VXLAN is configured over there. VMware provides you leverage to change this particular port if you want to, but do not change. In fact, I don't recommend it to be changed. All right. So though VXLAN is an industry standard, VXLAN is not configurable with regards to whatever switch you wish to. You know what? Just in order to configure VXLAN, we have to enable 4 features in a layer 3 switch. We will be looking at into it because there are significant configurations which are required, as I said earlier. So Cisco also has not provided VXLAN configuration capability with regards to each and every switch. The minimum switch which you need for Cisco Nexus operating system based is Nexus 5600 series switch. Nexus 7K, all the models they do support, but with F3 line card, right? And of course, 3 line card as well. And for this, what we can do is we can go back to our line card interoperability table, which we discussed in our, probably it was day 2 class on Nexus hardware. Then with regards to Nexus 9K, VXLAN configuration capability is available. It is available. You can configure VXLAN on all the models. And in our lab, we are also using Nexus 9K, but virtual. So Sean, my dear friend, which Nexus switch you are using for the purpose of VXLAN configuration in your EVNG?
Right now, I'm using a Next OS version. I'm getting the latest one, which is I think 10.1.2 or 10.2.1. It's a version 10. It's a version 10. The latest
Okay,
one right
but
now. Is
for which device? Is it for Nexus 9K?
Yeah, 9K. Sorry. Yeah, it's for 9K. Yes, it's for
Yes.
9K.
So, guys, we will be recommending this usage of this Nexus 9KV, probably in your CCIE data center lab, right? You will not have Nexus 9KV to be configured. The configurations of Nexus 9KVs is absolutely similar to that of the configurations for your Nexus 5600. There are certain slight modifications in the configuration in Nexus 7K in comparison to Nexus 9KV. Those differences we will also take a look, right? Because in the CCI data center lab, Cisco is giving us Nexus 7K and Nexus 5600, not Nexus 9K. All right, just a heads up. What is VXLAN? A little something more about VXLAN. Before that, as we know, this is an enhancement over our LAN segment. So let us look at into what VLAN gives us. VLAN has a limitation in terms of number of IDs to be provided. Total is 2, it is .1Q, right? IEEE standard .1Q. It is 12 bits identifier, which gives us maximum of 4096, and we know that the last VLAN IDs like 4044, 4046, 4048, they are very much reserved. So we are left with say few VLAN IDs and 4000. What VXLAN? Because of the multi-tenancy environment, it says that 4000 VLAN ID is not sufficient, because say I have hundreds of customers and each customer is asking 40 VLANs, then I'm totally exhausted. In case of a multi-tenancy environment, that's a reason the VLAN is published with not 12 bits, but it is with 24 bits, which gives you a total of 16,777,216 IDs, right? Sometimes it becomes so difficult to, pronounce this huge, humongous terminology. So, what happens? Normally, you will happen to see the documents and the guys, they are just saying approximately 17 millions. But I would request you to make it a practice of calling it 16,777,216, which really looks humongous number. Now, definitely there will be a question, what for? What the heck is it, yeah? What we are going to do with this, right? And in short, simple, crispy words, I say that this is the way we can use the same VLAN ID, right? And could be mapped with a different VN ID. And this is nothing but this is the beauty of multi-tenancy. This provides us multi-tenancy environment. Practical application, we'll see. Without doing it practically, you will not be able to understand it much. So it allows layer 2 multipathing, which is nothing but, guys, this is known as ECMP. There is a question, please keep the question with you, and meanwhile, anytime you can give me answer till this journey is on. Well, this journey has two phases. One is theoretical understanding, one is practical. Before moving over to the practical, if you happen to give me a chance, then you will get, $1 million for your correct answer. I will keep on giving you hint to give me the correct answer, that how this multipathing is achieved, that is how ECMP is achieved inside our VXLAN. Multipathing means what? Multipathing means, I'm not going to ask you what is multipathing. That is my responsibility to explain to you right now. Multipathing means wherein a leaf switch is connected to multiple upstream spine switches. The traffic comes to a leaf switch. The traffic could be sent onto all the uplink ports. VXLAN provides this beautiful functionality with the help of something which is dash dash dash. Currently, there is an ambiguity I'm establishing for you guys to find out so that you can grab $1 million, right?
So it should be equal cost, right? It should be equal cost multipathing.
Yep. Yeah, it is called equal cost multipathing. Equal cost. Equal path means yes, based on the cost calculation.
Sorry, Ashish.
Yeah,
Hello,
please.
uh, Sean here. Okay, I just
Sean.
want to, yeah, just want to some clarification. You have written here that there is a how you call this, a mapping between the VLAN, which is on the VLAN right now that we have is only 12 bits, which is only around 4096 VLANs ID that we can assign to our customers, right? And on the VLAN ID, there is a mapping to VNID, which is on the VXLAN, which is in the VXLAN already, which has already have a 24 bits for that, which is costing around 16 millions, around 17 millions approximately, as you write here. So there is a mapping for that. So is it mean that if, let's say, in the old days, the VLAN is sufficient enough. Let's say the VLAN last time, if they don't assign it in 12 bits, they assign it in a 24 bits. So it means right now that we do not need to map between VLAN and VXLAN. Is my understanding correct? Just to
You can say
extend
so.
the VLAN from
Hmm?
one side to another side.
Yes, you can. Your understanding is correct.
Okay. Because right now I'm getting the understanding why we need to map the VLAN with corresponding to VXLAN, or I mean it's VLAN ID, sorry,
Mhm.
VLAN ID, which is 12
Uh-huh.
versus 24. So I thinking that because of the shortage of the VLAN, and we need to extend it into from one site to another site via EVPN, BGP EVPN. That's the thing. That's the reason why that we need to map it, right?
Correct, correct, correct.
Okay, okay.
You're,
Thank you.
So
you're
Ashish,
welcome, my friend. Yes, Kamal.
so does that mean that a VLAN 40 of customer A is going to have a different VN ID and VLAN 40 of customer B is going to have a different VN ID, and this is how we will just make them unique, right?
Absolutely 100% you are correct. Two
All
customers,
right.
they can have VLAN ID but different VN ID. Absolutely
Got it.
correct understanding.
Hey Asis, if you remember yesterday, I asked you the one question, right? There's a difference between the older architecture, the layer 3 architecture, and the layer 2, right? The span and leaf and the traditional, the access and distribution layer. So this is the reason why
Indeed.
in the multipathing is supporting the span and leaf. That is not possible in the normal, like, the access and distribution layer.
Absolutely. In case of traditional network setup, beautiful question, Law, you asked yesterday, and beautiful point you have picked up today. Absolutely.
So,
In
so this
case
is the
of
only one reason, right?
yes,
Yeah. Another
in
question.
case, okay. Before the beauty is all the uplink ports are in use in case of VXLAN. Next question, yours.
Is it going to provide the end-to-end segmentation?
Is it going to provide end-to-end segmentation?
Like we
Segmentation.
say, like Kamal said that, like, the customer A has a 40 VNI and customer B has a 40 VNI. So it's like a, end-to-end segmentation we happening, right? We are going to make a
Uh,
overlay tunnel.
uh, what do you mean by segmentation over here? I'm just trying to look.
Segmentation in the sense, like, the information will be not leaked from one customer to another customer.
Absolutely 100%.
Okay.
And it is going to happen by the virtue of VRF, virtual routing and forwarding. All
But
right. We
VRF is locally significant, if I'm not wrong. If I'm not 100, but
very good
VRF is,
point.
yeah.
VRF accepts the traffic from one customer, right? And you will see that this VRF, after accepting, getting the traffic from one customer, will will send it to the VXLAN, which provides end-to-end tunnel and encapsulated secure tunnel for a dedicated customer. That is VRF. We are going to look at into it in the lab, and I'll show you there.
Hey, thanks, Asis.
This is
Yeah,
definitely going to be entertained in our lab. Yes, law.
yeah. I think the one who asked just now is Kumar, right? Yeah, Kumar. I think in continuation to what Ashish mentioned, if you are speaking with VRF, every customer that is received, I mean every switch, spine leaf switch that is where the customer is received, there will be it will be tagged into a BRF. Then on that BRF there are some fields there that we need to put like route distinguisher and route target. So in that route distinguisher, it will separate the a customer. So I have customer A, customer B, same subnet, let's say 10.0.0/8, both of them the same. But even though overlapping IP, but since they are in different route distinguisher, they will be they will not link to each other. So that route distinguisher will maintain all the way to the other side. Okay. Then once received on the other side, there will be another field that will import and export. So this route target that will import and export will be the one to distinguish which customer that you will be facing on the interface. I think that's what you are talking regarding the what they call that segmenting, right?
Yeah, Sen, right, you're right.
Sounds Beautiful explanation. And Law, if you know about the route distinguishing and route target configuration in MPBGP, I think you would
Right.
have understood. If
Yeah, that's going to provide the layer 3 segmentation, right? But here with the VXLAN is going to do the layer 2, right? If I'm not wrong.
absolutely. Identification, this is called concept of identification of the customers and deciding who can talk to whom, which customer can talk to which customer. That is nothing but that is governed by route target. Anyway, we are going to have a detailed discussion in VXLAN theory session and the application in our lab for this. All right. Good guys, good questions, good interaction. I really appreciate it, and that's the reason, you know, this 5 a.m. batch is one of my most favorite batch. The you guys do in the morning, early morning, you guys have full energy, and so I do. All right, VXLAN. VXLAN provides multi-tenancy. We have already spoken about it. The multi-tenancy in VXLAN, we are going to look at into in terms of configuration, how this multi-tenancy is achieved in VXLAN. Coming back to the terminologies again. Underlay, now I'm sure you are comfortable with what is underlay. Underlay is nothing but something, routing which is provided to perform the reachability. To ensure reachability, it can be provided using static way or the dynamic way. Here in terms of dynamic way, we have one beautiful industry standard protocol called OSPF. So we will be using our OSPF. And I'm sure everyone know how to configure OSPF. Well, we will not be going into the nitty-gritties of multiple area OSPF here in this particular scenarios. In VXLAN purpose, we will be configure a single area OSPF. All right. Then VXLAN is nothing but it is an overlay network, and it is going to be our responsibility to configure VXLAN using multiple tools, right? Multiple features. VXLAN stand for Virtual Extensible Local Area Network. V and ID are nothing but 2 raised to the power 24, 16,777,216 values. Right? VTAP devices are nothing but these are the hardware or software switches, right, with the capability of configuring VXLAN. These VTAP devices, if you have a VTAP device, these VTAP device, they have an interface, and the name of that tunnel interface from where the tunnel begins is known as NVE, Network Virtual Endpoint. Guys, during the course of our configuration, we will be configuring our NVE. We will be simply specifying interface NVE1. Please do not forget the full name of NVE. It happens when we go ahead, we tend to forget because we will be calling it as NVE, NVE, NVE. After a few days, if I ask you what is NVE, you should be able not only to give me the definition, but the full terminology of it. Network Virtual Endpoint. All right. Then we come to another terminology called bridge domain and VN segment. Guys, bridge domain is a terminology which is extensively used for the purpose of configuration in our Nexus 7000. The bridge domain is nothing but this is, let me clean it to write more. Bridge domain is a terminology which is similar to that of VLAN. Bridge domain ID called BDI is nothing but it is VLAN ID. VLAN ID. Bridge domain during the course of configuring our Nexus switches, Nexus 7K switches. When we need to create a VLAN, instead of calling it as VLAN, Nexus 7K call it as a bridge domain. Well, the same terminology, right, we will be using in our ACI. Bridge domain is a broadcast domain, right? So in ACI, we will be using it in a different way. Then comes the VN segment, and it is analogous to the VLAN segment, which we talk about. As I said, we will be mapping our VLAN with VN ID. So the segment where VN ID is mapped, that segment is known as VN segment, and where VLANs are defined, that segment is known as our V or LAN segment or VLAN segment. We have seen in our previous slide a terminology used as LAN segment. Hope this makes sense as well. Okay. Frequently, we are going to talk about these terminologies. We have underlay, we have spoken about it. We have this LAN segment over here. We have discussed about it. Physical server, virtual server, edge devices. And in case of, we have VXLAN overlay, internal endpoints we have discussed about. VXLAN gateways are nothing but they are our VTAP devices, right? That is the VTAP switches where our end host, that is servers, are connected to. Servers understand them as what? As their VXLAN gateway.
So those servers are VNEs, right?
Those servers are what?
VNEs.
VNE, VXLAN network endpoints. Well, VXLAN
Yes.
network endpoints. This terminology is not there. Are you talking
So
about
what?
NV?
Yeah, sorry, NVE. Sorry.
No. Servers are not NVE. NVE is interface over here.
Okay.
NVE
Okay.
is interface.
So on those VTEPs, the interface are called NVEs. That's what you mentioned?
Absolutely. On the VTAP devices, VTAP switches, right? The interface is known as NVE.
Okay.
I'm just going
And that
slowly and slowly. Yes.
and that helps to perform the encapsulation and decapsulation, if I'm not wrong.
Absolutely. The encapsulation and de-encapsulation happens over here. This is indeed responsible for encapsulation and de-encapsulation at the other end.
And this IP should be reachable to end to end.
Indeed, the IP we do specify on the interfaces. These are the IPs which we do see. And yes, they have to be reachable end to end. Okay. Himanshu Shekhar Sahu has arrived. Thank you so much, Himanshu, for joining.
Ashish, this is Shiva. So you are talking about OSPF, right? Is that OSPF only using for communication between the VTAPs, or any other dynamic protocol is using, like EBGP or ISIS, like that?
Okay. EBGP. We do configure MPBGP. We do configure OSPF, right? I'm not ISIS over here, but they are configured purposely. VXLAN, Deployment mode called MPBGP EVPN needs MPBGP to be configured, but its previous deployment called Flood and Learn doesn't require MPBGP. I'll tell you the purpose why MPBGP is, right? Immediately on a single day, I'm not going to tell you everything, and fine, because
Sure.
you will not be able to grasp everything on a very first day of VXLAN. This day is our beautiful day to understand what is this, to just do a handshaking with VXLAN. So we have spoken about the difference between VXLAN and this. Again, the terminologies: VXLAN segment, VXLAN gateways, NVE, right? All right. Bridge domain, VN segment. Now, I would like to take you guys to the inside story of VXLAN, which means what? Which means understanding VXLAN packet as captured by Wireshark. So this is a Wireshark capture of VXLAN packet. Then we will understand VXLAN frame format, the entire packet and all the fields in it, and how this is created. First of all, I have a simple question over here. Seeing the entire output, can you tell me what kind of communication packet is being captured between two endpoints by Wireshark?
It has
I
a
see a question.
destination UDP port of 4789. So that's kind of communication. Yep.
Okay, good capture. But well, UDP is a header.
I
One
think,
of the
yeah, I think the communication between host to host here is, because I see it's an ICMP, so I think it's a ping between from source to destination.
very good, Sean. It is a ping packet which is being captured where it is mentioned. Uh, okay, it is an ICMP packet, right? A communication, a ping packet between two VTAP devices is being captured by Wireshark. Now let us take a look the contents of it. Attempt is that a source 10001, which is an endpoint, right? Point to be noted, it is an endpoint, is attempting to reach to a host 10.0.0.12. You may be thinking, right? They are in the same network, they are connected to the same switch, then why Wireshark capture is required? Guys, just assume, okay, let me draw it, that there are two, the scenario is there are two leaf switches, say leaf 101 and one leaf 102. There is a endpoint here and there is an endpoint over here. Between them, there is a tunnel which is created, right? IP address of this is 10.0.0.1 and IP address of this is 1. Okay, 10. Okay, this is 11. And IP address of this host is 10.0.0.1. This Wireshark is sitting over here and is capturing the communication which is happening across a tunnel in between two leaf switches, wherein the endpoints, they are connected to two different leaf switches. The connectivity is not a plain connectivity like wherein we may think, oh, these two devices are residing in the same switch, right? Or in case if the devices are in a same broadcast domain, layer 2 broadcast domain. No, it is not this. The connectivity is where the leaf switches, right? They are not connected to each other, but physically they are connected to a spine switch. We have created a virtual tunnel between these, and Wireshark is attempting to capture the information, that is the information which is traveling inside this particular tunnel. All right, now coming back, ICMP, Internet Control Message Protocol, that is, it is a ping packet wherein the source from where the traffic is initiated is 10.0.0.11 and the destination is 10.0.0.12, the remote. It is not local to the same switch. We understood. Now, every host has an IP address. Along with the IP address has a MAC address. So MAC address of both the source and the destination is also being captured. Wonderful. Now, if you further take a look, the MAC address, that is the line card, right, is starting with Intel. So, and destination line card is also with Intel. This means it's an Intel LAN card in the host machines, having the MAC addresses over here, right? Then on what? Then, in order to send it to the tunnel, the very first encapsulation comes, which is nothing but which is our VXLAN encapsulation. What we have got a significant component over here, which is called VNID, mentioned to us. Is it in a hexadecimal? No. This is a replacement of the actual VLAN which came to the leaf switch. The very first encapsulation, we are going to, call this with a name called Shim Header, right? We will see what is this Shim Header, from where this terminology is used. This is not the terminology which is written in the IETF RFC 7342, right? This is a terminology which Cisco gave in OTV, and I'm using this terminology with your permission. I do not have permission from IETF, Internet Engineering Task Force, who has the white paper on VXLAN. So we call this as a shim header, a component, a washer, which joins two pieces together. So what is the other piece? The other piece comes is, on top of it is UDP. UDP is used purposely over here with a specific purpose. If we take a look on the UDP, UDP has a source port of 39965 and a destination port of 4789. This 39965 is not fixed, it is a dynamic. For our other stream of the traffic, this could be a different number taken from the dynamic port range, right? And this particular port, that is destination port, is fixed unless and until you get a leverage to change it. In VMware NSX network virtualization, VMware provides you a leverage to change this particular destination port, but in Cisco, I do not know the command in case if it is there to change the destination port number, destination UDP port number. You can change it for your own convenience to enhance the security, because the world at large knows that this is a destination port number. They can capture the traffic because VXLAN do not provide you encryption, right? So VMware NSX V and NSXT solution provides you a leverage to change this destination UDP port number if you wish to. All right, then what? Now we have to make sure that this packet gets moved out of our VTAP. So that is the reason the final encapsulation is your IP encapsulation, wherein you provide the source IP and a destination IP. This source and destination IPs are the IPs. This is your VTAP. This is your interface NVE. So this IP, the source IP is IP address of this leaf 101, and destination IP is the IP on the interface NVE interface on your destination switch. Now, so this entire packet can, all right, so of course with the IP address we have corresponding MAC address also. This entire VXLAN packet could be divided into three major components by us. One is the very first, you can say inner, then you can call this portion to be as shim, and you can call this portion to be as outer header. Inner frame, and you can call this to be as a outer header, and shim header you can call this if you wish to. But shim is not an IETF terminology mentioned under RFC 7342. Please don't blame me if you don't get a chance to find shim. Okay. This is about our VXLAN components. Okay, there's a question, right? Question is, what is shim? Can you show us shim? Why not? Let us take a look. Let us ask Google to give us what is shim. Shim, and let us look at into the images. Guys, this is called shim. A washer. This is called a shim. So what this VNID is doing? VNID is shimming. VNID is joining, right? Two kinds of headers, inner header and outer header. And this is nothing but this comes by the task called replacement. All right, any question with regards to this? Please let me know.
Ashish?
Yes, please.
Yes, I have one doubt. So in this capture, do we get to see the VLAN ID anywhere?
All right, since the question is being asked, so it is my holistic. So we are not able to see the VLAN ID over here in this Varsha capture. And why we are not able to see? Because the moment this layer 2 classical Ethernet frame reaches to the switch, right? The very first replacement which is done, right? There is first replacement is done inside the switch. Second encapsulation, further encapsulations are done on the NVE interface. Inside the switch, your 802.1q header is removed and is replaced by your VNI, right? So if you take a look on the final packet or the frame which gets formed, you don't get to see the 802, that is your VLAN ID, where this replacement happens. The replacement happens inside the switch. So our capture is on to this particular tunnel. So hope you get the answer to your question, my friend Anand.
Yes.
Yeah, thank you, Ashish. I mean, I didn't ask that question. Question is asked by
Okay.
Vignesh. I mean,
Okay, Vignesh. Hope you got the answer
Yes.
to your question.
yeah.
Yes. So, but one more question. This removal of 8.2.1q and addition of the VNI is taking place in the NV interface, right? In the packet
No,
reaches NV interface or the source interface.
uh, no. The point is, and this is a very important point to be noted, guys. This replacement, right, during the course of your, again, the lab, since this question is being asked, and I'm sure if you understand this, you will be able to understand the sequence of our configuration. All right. Coming over to answering your question. We have host over here. We have a VTAP over here, right? We have NVE interface over here. What we are going to do, first of all, say from a VLAN 100, one request will come to the VTAP. There are certain configurations which we do in VTAP. What for? For the purpose of VXLAN. The replacement of 100 to 50100. This replacement is done inside the VTAP. Once this formalization is done, once this replacement or swapping is done, then the traffic is sent to this NVE interface. NVE interface does acknowledge this replacement and forwards it outside. But originally, the replacement happens inside the VTAP and not on the NVE interface. There are few configurations which we do in NVE interface. Majority of configurations we do in the tunnel before even giving the VXLAN packet to the NVE interface.
Yes, clear.
Okay, good question. It is absolutely a legitimate question, because based on this question and the explanation, we will be doing our lab, right? All entire lab is based on these questions only, and without lab, understanding is incomplete. Yes,
Hey,
guys.
uh, quick question. Okay, see, take example. We have a one location in the Delhi and another location in the Bangalore, right? And we are making a layer 2 connectivity between the Delhi to the Bangalore. Now, the thing is that, for example, if the packet arrived on the switch 1, okay, and that has a VLAN number 10, that is a classical Ethernet frame, right? And once this frame will be adapted to the the VTAP, so VTAP will remove that classical Ethernet frame and it will send on the overlay. Okay, once the another side will receive it, so after receiving, what happened, they will perform the decapsulation. But then how does the another side will decide, should I forward this frame to the VLAN number 10 and 20?
Okay, very good question. Guys, okay, Law Kumar, could you
Because
please check?
yeah,
Okay, I got your question, right?
okay.
Could you please check your bank account? You have got just $1 million in your bank account. You know what? It's a beautiful question. So let me explain, give answer to this question before concluding today's class. Answer to all my questions, you will guys find in the configuration. Okay, first of all, let me explain that what actual question is. We have got a VTAP device over here, and we have got a VTAP device over here. This VTAP device is connected to the spine switch, and okay, let me get my brush.
So Ashish, this is the role of VNID, right? It will be a unique one, which will be a combination of VLAN and the number, right?
Yes. Okay. So the question is, we have a host sitting over here, and this host belongs to a VLAN, say 140, and there is his partner sitting over here, and he is also into the same VLAN. Now, I said whenever this particular traffic from 140 will come to the VTAP, what VTAP will do, VTAP 101 will say, dude, you are getting removed and replaced by 50140. And then the traffic will be sent across the tunnel, right? Wherein inside the tunnel on NVE interface, only Mr. 50140 is traversing. That's what we capture. Only VNID is here. Now the question comes is, when this traffic will reach 108, how 102, how 102 will identify that 50140, which is our VNID, is linked to Mr. 140. Correct? This is the question. Law?
Yes, right.
All right. My dear friends, let me tell you, absolutely a brilliant question. And answer to this question is, there is a mapping. VLAN 140 VN segment 50140. This is the command which we do for the purpose of this mapping. And you know, the same command is given on all the leaf switches. All right, which means the same command is given in 101, 102. So consequently, when this 50140 comes to 102, 102 knows that 50140 is mapped statically with me with 140. So what he does? No doubt, beautiful. Give it to him.
Awesome. We can do the dynamic mapping as well, as, if I'm not wrong.
No, man.
We cannot do
It's
that.
all. Well, dynamic mapping happens. Dynamic mapping happens, right? But it happens in your ACI fabric.
Okay.
Where even all configuration is dynamic. VXLAN does run in ACI fabric, but it's all dynamic, all automatic. You need not bother about even a single configuration in ACI fabric. But yes, you can see by running.
Of course, the lots of header is being added by the devices. So you may need to change the MTUs as well as, right?
Additional 50 bytes of load VXLAN puts in. Consequently, my dear friend, you are absolutely right. We need to increase the MTU size. And 9,200, we just allow jumbo frames. And this has to be done, you know, and to and. Dear friend Sean, if you grabbed the initial configuration from our lab, right? You must have noticed, I'm sure, you must have noticed that MTU is already configured on all the layer 3 interfaces.
Yes, it is emphasized.
Right? So
Correct.
this, guys, in DC Lab version 2.0 and in 2.1, this was part of your T shooting. Cisco will give you pre-configured, partially pre-configured lab, right? Say in some of the interfaces, MTU will be missing. MTU and to and must be same. And you know, MTU plays a significant role in underlay also. For what? For what? Can anyone tell me? MTU role in our underlay?
Avoid the fragmentation.
OSPF neighbor relationship
Start state
gets stuck
and
into X state.
for exchange state.
Yes. So, all right, this is all going to be handled in the lab. Well, any other question you have?
Ashish, yeah, as you are talking about the MTUs, let me ask you one question. So here, I mean, the negotiation will happen, right, for the MTU. If one host is 1500 and another one is jumbo frames are allowed, then it will automatically negotiate, right?
Another beautiful question. One thing, two interfaces. Let me clean this. And Control A and delete. MTU has a simple funda. And what is that? Fundamental base of MTU is two different interfaces, right? If MTU here configured is 9216, here MTU configured should be the same, 9216. This is the prerequisite for OSPF. In our lab, the lab which we are going to do. Sean, can you tell me how much MTU is configured between spine and the leaf switches?
It's I think my lab is closed. I think it's 9,200.
Absolutely. Now, here comes the answer. In our lab, the lab which we will be doing, right? This is our spine one, this is our leaf one, this is our leaf two. We will be configuring MTU over here 920, 9200. We will be having an extension of this particular leaf switch to the outside world, right? Wherein we are going to have our WAN router. And my dear friend Sean, can you tell me how much MTU is configured here and on this interface?
That one I cannot remember, but I think it's a default. I cannot remember anymore. I think it's nine. Let's say 9,000. Yes, something like that.
No, the MTU configured is 9216, right? However, the MTU configured on in between the spine switches and the leaf switches is 9200. This means in case, what is the prerequisite? The traffic flow is like this and vice versa. The physical path is going over here. VXLAN's requirement is additional 50 bytes, right? Over here in between these two interfaces, MTU is more than 9200, but what it is, we know that over here, from over here, we are not getting a jumbo packet, right? But here we require a jumbo packet. So the packet definitely, the actual size of the packet will definitely be less than or equal to 9200. So when a packet will come to our VTAP, right, it will be a packet less than 9200. So it will enter in our VXLAN fabric. So now about your side, about your question. If I have understood your question correctly, Anand,
Yeah,
MTU face-to-face interfaces, right, should always be same. This is the
okay.
prerequisite of MTU. But MTU on this pairing devices or the networks could be different from the network. So in VXLAN 9200, but in our traditional network, we are good with 9216.
So
Does it answer the question, Anand, if I understood your question correctly?
Yeah. So I mean, you are saying that in the traditional network we can do, but in the VXLAN we have to, or we should use that 9216 or EMTU. I mean, jumbo frames should be allowed for the VXLAN communication. I mean, if it is a direct pairing, right?
Yes. Yes.
Okay.
Right.
Okay. Thank you. Thank you.
You are welcome, Anand.
So is that the case? As is the jumbo frame get configured in CE router also from ISP end?
Jumbo frame is also configured. Well, it is yes.
Okay. So if you are deploying VXLAN between the two sites, for example, two data center, so we need to put a request to ISP also need to get configured jumbo frame at CE router, right? Since the packet is get traversed.
Yes, please do. Yes, please do request, because the frame is going to be more than 1500 byte, right? And the holistic practice is when it is more than 1500 bytes, please specify a jumbo frame, say based on your router's capability, right? Make it jumbo, and end to end must be same. That is face to face, it must be same between the two peers,
Okay.
right? Okay.
Yeah.
Guys, any other question? All right, then done. I have taken 10 minutes extra from you guys. Thank you so much for joining, and those friends of ours who have joined for the first time. Yes, our dear friend coordinator will reach out to you. You can definitely share your feedback. Please do share your feedback. And this class will not at all stop until we will finish VXLAN. Of course, not Saturday, Sundays.
Hey,
All right.
Ashish, sorry. There will be a link for recording for this one, right? That we can see again or watch again, something.
Yes, Sean. I hope you have signed up in our site. One
Yes,
second.
yes, yes,
Let
yes.
me request, ma'am. You have